Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for inserting an interval in an sorted interval list. Let's look at the problem description. We are given an array of non-overlapping intervals. All the intervals are sorted based on the starting time. Okay, and we are given a new interval. We have to insert that into that list such a way that if there are any overlaps, those intervals should be merged together. And finally, we have to return the new interval list. And also we don't need to modify the intervals array. Instead, we can create a new one and return it. Okay. Let's look at the example one. The interval has 1, 3 and 6, 9. The new interval is 2, 5. So in this case, 1, 3 and 2, 5 are overlapping. So we combine both of them and create a new interval 1, 5 and add it in the output list and 6, 9. Next, let's take a look at the example 2, which has 1, 2, 3, 5, 6, 7, 8, 10, 12, 16. So the new interval is 4, 8. This interval has overlap with this and this and this intervals. Okay. So first so the final output will be in that case 1, 2 and the minimum of the start time of the new interval and the overlapping intervals, in this case 3. So 3, maximum of end time. So in this case 10. So 3, 10 and then 12, 16 will be added. So the final output will be 1, 2, 3, 10, 12, 16. So the interval array length is ranging from 0 to 10 to the power 4, 10,000. And the interval's length is 2. So the each has the start and end time. And then the value for the start and end will be 0 to 100,000. The intervals are started by the start time in ascending order. And the new interval length also 2, this, the length of this input. And the start and end will be 0 to 10 to the power 5. Let's look at the approach to solve this problem for this input. So the expected output will be 1, 2, 3, 10, 12, 16 because this interval is overlapping these three intervals. All these three intervals will be merged together and we added that in the output list. We can solve this problem by scanning this array once. Starting from index 0, we traverse the array until the end of the array. Initially, this read index will be advanced until the first entry which has the overlap with the new interval. Okay, so that is what we are doing here. If the end time of the current entry pointed by the read index is less than the start time of the new interval, then we can advance the pointer. That means there is no overlapping, so we can simply move forward to the next element and check whether there is an overlap. Once we find the overlap, we update the new interval's start time between the first entry which has the overlap, the minimum of the start time of the first entry that is overlapping, and the new interval. So between these two, 3 is lower. We can update the new interval with starting time as 3. After finding the first element which has the overlap, we try to scan the rest of the elements until we find an element which is out of this end time. Okay, so in this case, once we find that this element has an overlap with this, then we scan this, and once we reach here, this element is out of that interval 8. Okay, then we update the end time of the new interval between the highest value of the end time of new interval and this. So now we have a 3, 10. Then we add that 3 comma 10 to the output list, and then once that is done, we break out of that loop. There will be another loop which scan through the rest of the array and add all the entries to the output. Finally, we have an array which has the new interval added to it, and also there will be no overlapping among those intervals in that new output array. So in this approach, the time complexity is order of n and the space complexity is order of 1. Let's look at the flowchart. Input for this procedure is an intervals array and a new interval. First we initialize the read index to 0 and count the number of elements in the array, and added boolean which indicates whether the new interval is added into the output list as we traverse the input array, and then the output slice where this new interval will be included. Next we enter the outer for loop. We check whether we processed all the elements. If there are any pending elements, then we check whether the current element's end time is less than the first we check whether the start time of the new interval is greater than the end time of the current intervals pointed by the read index. In that case, there is no overlap between the new interval and the current interval. So we add that current interval to the output array and increment the read index to process the next element. So if there is an overlap, then what we do is we update the start time of the new interval with the value that is minimum of the current interval start time and the new interval's start time. Okay. Next, we traverse the rest of the elements until we find an element which is outside the new time interval. Okay. Once that is found, we mark the added flag to true. What we do is we first we merge the intervals by updating the end time of the new interval variable. Then we break out of the loop, and then we update the added flag with the value true, indicating that we added the new interval into the output list. Then we come out of the loop. We break out of the loop after doing that. Once we come out of the outer loop, we check whether the added flag is true. If it is false, that means in the input list the new interval do not have any overlap. So we have to add this new interval at the end of the output list. That's what we are doing here. Otherwise, there may be a pending elements in the input array. So we have to add all the remaining elements in the input array to the out array. Then finally we return the out array. Let's move on to coding. First, let me define the constant for the start and the end indexes for readability purpose. Then I initialize the inside the function I initialize the output array empty slice, and I initialize the count variable with the number of elements in the input interval. Then initialize the boolean variable to indicate whether the new interval is added or not. It is initialized to false. Then I initialize the read index to 0. Then writing the outer for loop which runs count number of times. Each iteration I check whether the current interval has an overlap with the new interval. So I am checking the new interval's start time is greater than the current interval's end time. That means there is no overlap. In that case, we simply add the current interval to the out list and check the next element in the input array. If there is an overlap, then first thing what we do is we update the start time of the new interval with the value that is minimum of the start time of the current interval and the start time of the new interval. Next, I write the inner for loop. The purpose of this for loop is to find the last element in the rest of the array which is outside the new interval's time limit, end time. First I check the current element's start time is greater than the new interval's end time. That means the current element is outside the time interval of the new. Next I check whether the current interval's end time is greater than the new interval's end time. That means the new interval is between the current elements thing that is overlapping. So this the current element is also part of the merged interval. So I for the next time we have to process the element which is following the current element. Next we have to update the end time of the new interval with the end time of the current index in this case, because we are including the current element also as per in the merged list. Once we found that element, we break out of the loop in both the cases. Then I increment the read index in the inside the inner loop. Once we break out of the inner loop, we will have to add the new interval to the output list. After adding that, we have to mark that new interval is added to the out list. So we set that boolean variable to true and then break out of the outer loop. Once we come out of the outer loop, we check whether the new interval is added to the output list. If not, that means there is no overlap between the new interval with the all the intervals in the input array. So we simply append that new interval at the end of the list, output list. Otherwise, there may be some element left in the input array, so we have to add those leftover elements to the output list. So that's what this last for loop is doing. Finally, we return the output list. Next, I'm going to run the test cases. Some compilation error. Oops, I missed a semicolon. Let's fix that. Have to pass the start value. Okay, all the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. Let's do the code walkthrough for this input data. The expected output is 1, 2, 3, 10, 12, 16. First we initialize the output array to an empty list and initialize the count with the number of elements. In this case it is 5. Then I initialize the new interval added flag to false, and then the read index will be initialized to 0. Okay, so the read index is pointing to the 0th index in the input intervals array. Then we are entering the for loop. Okay, so in the outer for loop iteration 0, when we enter the read index is 0, the new interval is 4, 8, and the added flag is false. In each iteration we check whether the new interval start time is greater than the end time of the current element. If so, there is no overlap between this element and this element, so we simply add this interval to the output list and advance the pointer. We'll move on to the next iteration. Okay, we are continuing. So in the next iteration, iteration 1, the read index is pointing to the index 1, and again we are checking whether the end time of this index is greater than the start time of this interval. In this case it is true. That means these two entries have a overlap. Okay, so once we find the first element, first overlapping element, we update the start time of the new interval between the value of the start time of the new interval and the start time of the current interval. So in this case 4, 3, so 3 is the smallest, so we update 3. So that's what we are seeing here. It is 3. Okay, new interval will be updated to. Once we find the first overlapping element, we update the start time of the new interval with the value that is smallest among the current element start time and the new interval start time. So in this case it is 3. So when we enter the inner loop, we will see that new interval as 3, 8. Okay, so the purpose of this inner loop is to find the first element in the rest of the array, find the first element which is out of this interval. Okay, so that's what we are doing here. So in each iteration we check whether the current interval start time is greater than the new interval's end time. In that case we break out of the loop. That is for that indicates this element is not included in the interval. So in each iteration of the inner loop we check whether the end time of the new interval is less than either the start time of the current element or the end time of the current element. If it is less than the start time of the current element, that means the current element is not part of that merged interval array. That's why we are not incrementing the read index pointer here. If it is greater than the current element's start and less than the current element's end, that means the current element is part of the merged interval. So next iteration we process the next element. So in this case so when we enter the inner loop we start from index 1. Okay, we check whether the end time is greater than the start or end time. That means this element is included. First we check whether the intervals, the current interval start time is greater than the end time of the new interval. That means we found the boundary for the merged interval. So we are breaking out of the loop. So this checks the compares the new interval's end time with the current interval start time. So in this case, the condition is false. So we go ahead and process the next element. Now the read index is pointing to 6, 7. So this is also within the new interval. Both start and end are less than the end time of the new interval. So we are advancing the pointer to the next one. Okay. So in this case, the start time is within the boundary, but within that interval, but the end time is out of that interval. So in that case, we have to include this also part of the merged interval. So we will be updating the new interval's end time with the current element's end time. So that's what we are seeing 3, 10. Okay. And then we increment the read index because this element is part of the merged interval. So the next iteration has to process from this element onwards, right? So we are incrementing the read index. Here we are breaking out of the inner loop, and then we come back to the outer loop where we add that new interval to the output list, and then we mark that the new interval is added to the output array and update a set value true for that boolean variable, and then break out of the outer loop. Okay. So once we come out of the outer loop, we check whether the new interval is added to the output list. If not, that means none of the elements in the input array has an overlap with the new interval. So we are handling that case here, but in this case there is some overlap, so we will not hitting that condition. Instead we are hitting the else part where we have only one element. Okay, so right now the RIDX is pointing to the last element, so we will be adding that last element to the output list. So when we do that, the output list will have 1, 2, 3, 10, 12, 16. And finally we return the output array. Next I'm going to do the time and space complexity analysis for this solution. For this input data, let's see how many times this outer for loop and then this inner for loop and this the last for loop runs. Okay. So as per the code walkthrough part, the outer loop runs 2 iteration and the inner loop runs 3 iteration and the last loop run once. So totally it is 5 plus 1, which is the number of elements plus 1, so which is an order of n plus 1. So the time complexity for this solution is order of n. With respect to the space complexity, the space is allocated only for the output data. We can exclude that for a space complexity analysis. So except that, we do not allocate any other additional space for intermediate processing. We use only just few variables. So the space complexity for this solution is order of 1. Thanks for watching this video. Have a great day.